There are approximately 1,000 questions that I have on my list. So I guess there were a bunch of questions going all the way back to Chris Fuchs's talk. I hope Chris Timpson's okay if we jump around a little bit. I want to make sure people have an opportunity to ask questions. I will, given how many questions we have and how much time we have, prioritize people who haven't asked questions before. Okay. So the first question I have is, and this goes back to Chris Fuchs's talk, is from Adam Becker. Adam?
Hi, yeah. Actually, the original question I had was sort of answered by Chris Timpson's talk, but so I guess I'm going to ask a slightly different question. And this is a little woolly, and I apologize for that in advance. I sometimes think about an Everettian or many worlds view as being sort of like, okay, unitary evolution is the whole thing. And, you know, that's what we have to do. And that's where we get our picture of the world from. And then, you know, the problem for the many worlds people is, okay, where does everything else come from, including the Born rule? And I want to know if you think it would be fair to say that QBism is doing something similar, but putting the Born rule in place of unitary evolution.
Was that question directed to, yeah, Chris, go ahead.
To me. The emphasis of my talk today was on the Born rule playing a structural, kind of structural realist role in saying something about the world. Mm-hmm. The emphasis of Jacques' talk, to some extent, is a kind of opposite to Everettian view. And it's certainly one I endorse. So instead of saying everything is unitary evolution, that point of view would be something more along the lines of John Wheeler's thinking that everything is measurement, that measurement plays a fundamental role in the world. And ultimately, one wants to de-anthropocentrize the notion of measurement. So I've been on about this for years, and maybe Chris Timpson's the only one who's followed it, and it was Jacques to some extent. But I'm quite taken with some of the ideas of the early American pragmatists and Alfred North Whitehead, that the world is constituted of things that they called pure experience. But when they were talking of pure experience, they weren't talking in the Lockean notion of experience, that experience is something that's isolated to the head, but rather something that is at the boundary of the agent and the external world. Or maybe I shouldn't say at the boundary, but at the connection between an agent and the external world. And they wanted to abstract that away. They wanted to abstract that away from being particularly about human experience. And so it's a philosophy based on lots and lots of words, no equations. Now, Whitehead tried to remedy that by, you read in the introduction to Process and Reality that in fact he's not saying anything that Dewey and James and Bergson weren't saying, but he has made it more precise. So precise that I don't understand it. But I have this sense that in quantum theory, that project might be completed. And the Born rule now is expressive of some aspect of that. So the world is made of measurement. I'm going to put this in big scare quotes because it needs to be made more precise. And this is a large part of Jacques' research project right now. And Michelle Bitball has also been thinking about it. And in fact, all of us have, Marcus Appleby and others. But then one says, well, the character of the world is this stuff that brings genuine novelty into it. That is what the experiential factor is. The genuine novelty enters the world. And because of the particular character of that, one is well advised to use the Born rule in making one's decisions. So the Born rule is a higher level reflection of the deeper ontology, the stuff that Jacques was talking about. I don't know if that helps.
Oh, I think that does help. Thanks.
Great, thanks. Good question. The next question I have, again, for just following Chris Fuchs's talk, but also I know you had at least another question, maybe for Jacques' talk as well. Alex Meehan.
Yes, actually, my question for Chris was also answered in the intermeeting time, so I could ask a question to the others or hold off.
Please do, because you did put your name in the queue back during an earlier talk, so go ahead.
Cool. Yeah, so my question, I guess maybe I'll frame it in the terminology from Chris's talk. I sort of had a view in mind that was, maybe you could call it like extra light QBism, or maybe like just naive QBism. But tell me if this is the same thing as just light QBism, which is, I was thinking, what about a view which said there are, or at least may well be, underpinning microphysical laws, and there may be the fundamental laws at the micro scale, but those are laws that are for the discovery of future physics, maybe quantum gravity, maybe something even further down the line. And QBism as a view is sort of saying, taking as, or this, sorry, I should say, this extra light QBism that I'm sort of trying to toy with is saying, given the package of what we have with at least non-relativistic quantum mechanics and quantum information theory and so on, and maybe also a bit in, from what we know from QFT as well, the QBism picture is the best sort of intervening thing we can say. But let's not commit ourselves to what the ontology is. Let's just say that's a question for future physics. So I was kind of curious, maybe that could also alleviate some of the explanatory worries if you just say, yeah, like whatever the true most fundamental physical theory is, that will have explanations. But my job is to say this is our best account of this quantum formalism that we've been given in the last century or so. So I was just wanting to put that view out there and ask, I guess, all three about maybe why they don't go in for that view and how it relates to some of the other views that were on the table.
Shall I go first? From what you said, it sounds as if your QBism super light isn't a form of QBism at all. Unless you're wanting to say that it will be that no future physics will include any facts which make quantum states or Hamiltonians, etc., right or wrong. But if there are any kind of detailed fundamental laws there, then it's hard to see how they couldn't make some kinds of facts of that sort right or wrong, how they couldn't actually, as you said, give explanations of kinds of things in a way which would actually constrain us in ways that QBists have to insist that we're not constrained. So if one just wants to wait and see what happens, that's fine. So then I just recommend agnosticism about quantum interpretations. Maybe one of these patterns of interpretation will end up being something that's picked up by later physics. Maybe it won't. Maybe one of these interpretations will help us in developing future physics. Maybe it won't. But agnosticism is the view if you just want to wait and see what future physics says. I think QBism is quite demanding, and what it demands there isn't there.
QBism is the most apophatic of all quantum interpretations. We're more than happy to say what is not there, like apophatic theology. And we haven't been so positive in what is there. But to answer, my take on your question is, I would just say this, that the project of finding an ontology consistent with all that we know of quantum mechanics is, in my mind, a grand exercise in guessing new physics. And I like to use the example of Einstein's happiest thought in, I think it was 1907, when he guessed the equivalence principle. And then he pushed that to its logical conclusion, and that led to the space-time manifold. And and his equations of GR. Now, that was not an expression of all that he had seen. Instead, he had indications that the world is, sorry, I'm doing this too much. The world is like this. And now, over 100 years later, we're still finding gems within that structure that were hidden within it. And now we're detecting gravitational waves. We're understanding black hole collisions. Einstein did not foresee black holes when he wrote the equations. He didn't foresee gravitational waves necessarily. He bobbed up and down on them. But it was because he identified an ontology that he could push physics forward. And that's what I see as the exercise of a QBist ontology, that it will have hidden gems in it that we can't really imagine at the moment. And I just give these little, the equiangular line question. Right now, it's a mathematical question. And you might say it's nothing more than that. And the reason I wanted to have a solution is because I want my pretty equation to be true. And if they don't exist, then my pretty equation isn't so pretty and it was a mistake. But I dream that somewhere in there is hidden something so powerful as the recognition of black hole existence. But we won't know that for a long time.
I see. Thanks.
All right. I noticed, Alyssa, you had your hand raised. Did you have a question? I just noticed that you lowered your hand.
Oh, surely people were before me, but it was, yeah, it was addressed by, I was in the ballpark of Alex's question, so thank you, Alex.
Okay, I just wanted to make a note that your hand had been raised and I didn't want to miss it. Great, so the next hand I have was a private message in the chat, and I'm quite glad that this question came up in the chat, because I was wondering exactly the same question. It was about how to think about quantum state tomography in a world in which quantum states are subjective. So this is from Rick. Rick, go ahead.
Yeah, so this is just basically a confusion, I guess, I have about what it means for the state to be objective versus subjective. So there was a definition that Jacques gave, and it's talk about what the objectiveness might look like in QBism, where he basically said that anything that's sort of invariant under which observer sees it could be thought of as being objective. And maybe I'm misremembering the exact definition given. But, it seems like if you set up a lab and you set up your cylindrical thingy and you produce your electrons and you go in and you do quantum state tomography, anyone who goes in there and figures out what the density matrix of that electron is going to agree, right? So maybe Alice goes in and does it, Bob goes in and does it. And if they each take enough statistics to whatever precision you want, they're going to agree on the density matrix. And so it seems like in that sense, it's observer independent. So it seems like it would be an objective thing. So am I misunderstanding something here? Would it be fair to call that an objective thing in QBism? And I'd be interested for Jacques and Chris to answer that.
Well, in a way, that's kind of an easy one, because there's QBists have papers on that. But the upshot is that it's not trivial to say that two agents walking into a tomography of an electron source will necessarily come to agreement. So in fact, there are priors such that no matter how much data you take, the two agents will never come to agreement on what the density matrix is. However, it's certainly an interesting question to ask, what is the meaning of tomography in QBism? Because in tomography you're ostensibly trying to find out the unknown state of the system, but in QBism the state is your subjective beliefs about about the system. So it seems that if you already by definition know what the state is, so what is it that you're finding out? So that's basically the subject matter of the quantum Definetti theorem, which QBism has some papers about. I don't know if Chris wants to field that. Maybe it's fresher in your mind, Chris.
Sure, I could, if you want me to. You said Chris and Jacques. Which
oh,
Chris
sorry. I should say Fuchs and Timpson, but either one really.
Well, which did Rick mean?
Oh, I
Who
had
does he
meant,
want an answer from?
I know that you had some paper like the Hero's Handbook and stuff that talked about this a little bit. So I was referring to you, Chris. Fuchs.
Okay. Well, we have things much earlier than that because this was one of the first outstanding problems for QBism, or what was to become QBism. And that is, as I think I mentioned in my talk, oh no, sorry, that was this morning's talk. I've given a talk in Belgium today, and I've given a talk in Cambridge today. In the Belgian talk, I mentioned that the term unknown quantum state is an oxymoron from the perspective of QBism. If a quantum state is a state of knowledge, then there can be no such thing as an unknown quantum state. So what are people doing in the lab when they're performing tomography? And luckily, Bruno De Finetti himself had suggested the answer in 1932. And that is, in his day, there was the issue of an unknown probability. And for him, an unknown probability was an oxymoron as much as an unknown quantum state is for the QBists. So he had to give a personalist or subjectivist re-expression of what's happening in statistical testing when an unknown probability is identified. And the way he did that was he found conditions, the crucial assumption that's going on in finding an unknown probability and the crucial assumption of what's going on in, and we translated that into the quantum case. So in our description of tomography, an agent walks into a laboratory and he has an initial judgment that every instance of the system that's coming out of the device, he can interchange the two of them, any two of them, and it will lead to his same quantum state assignment on a big block of systems. There's only one agent here, and there's no unknown quantum state. There is his quantum state assignment that has the property of exchange symmetry. And you can prove that once you make that assumption, then your statistics, if you look at statistics, you will converge with probability 1 to a quantum state assignment for the individual systems. So this is a subjectivist reading of the issue of tomography. Moreover, you can prove that if two agents walk into the laboratory, both of them making this assumption of exchange symmetry, even if they don't make the same assignment, as they look at statistics together, they're both looking over the laboratory bench, then they will converge in their assignments. But what Jacques brought up is that we have examples where an agent can walk in and say, I assume exchange symmetry. And another agent walks in and he goes, hi, you just don't know those devices. They have drift, they change overnight, they change when the traffic drives by. I'm not going to assume exchange symmetry. And then as they look at the same data, they update and they don't end up on the same quantum state assignment.
I mean, is it fair to say in the case where there is exchange symmetry that the quantum state is an objective property of the system because everyone will agree on it?
I would prefer you put it like this. In the case when two agents have assigned exchange symmetry, they can act as if there is an objective quantum state assignment. But conceptually, it's the wrong thing. But they can act as if. This is the sort of thing that Chris Timpson wants in his QBist light. That at a sufficiently macroscopic level, you can act as if there are stabilized facts, and it won't get you into trouble. And so in the case of exchangeability, I'll say, yep, that's good. I prefer you not use that language because it will trip you up conceptually, but it'll work. In the case of Chris Timpson, we're still working that out.
I would add to that, so for me, I think the thing is that you're restricting to a subset of agents when you say, if we presume that they assign exchangeable priors. But usually, we want to be fairly expansive and consider even agents that would not necessarily assign exchangeable priors. So as long as you're taking a fairly expansive set of agents in mind, then that state assignment is just not going to be invariant across all reasonably conceivable agents. And that's why I would tend to not want to say it's objective. I might be willing to say it's objective relative to a subset of agents. Maybe.
I mean, I guess you would say that it's not fair to say whether the exchange symmetry is really there or not, that that's not an
Exactly.
objective.
That's the key point.
Okay.
Yeah.
Great. That also clarified the question for me too. The next hand I have is from Jerome.
Hi. This one is for Jacques. More specifically, so in your response to some objections against novelty, in your paper, you presented something like, once one outcome occurs, it's more likely to occur that way in the future. And I was just wondering what sort of justified that, if this was coming from some principles in quantum Bayesianism, because it just struck me as a bit ad hoc, but I also don't know a ton about QBism specifically. So I'd love a little bit of clarification on that.
Well, let me ask you this. If when Einstein says the speed of light is the same independently of the speed of the source, would you call that an ad hoc principle? You might. I wouldn't necessarily object, but I think it's not really ad hoc because it is based on experience. I mean, one has reasons looking at experiments to think that it might be true. And I kind of view this repeatability of measurements the same way. You know, we fiddle around with devices and measurements, and we find that we can carefully set it up so that if we, you know, press the button and do just the right thing, we find that we get the same result again and again in a sequence, you know, up to a point until drifts or takes over or something. So for me, that's just an empirical fact about the world that we have to accept and take as a postulate.
Okay, so this is sort of hinges on the fact that we try to reproduce certain experimental conditions when repeating measurements, it seems.
Yeah, exactly. I mean, I don't think there's anything in QBism or, you know, as such, or a Bayesian approach, which guarantees that the world is such that science is possible. You know, I think we kind of have to postulate that, you know, it is the nature of the world, you know, that certain things, the world is a certain way that allows us to do science in it, which we're eternally grateful for.
Wonderful, thank you. That definitely cleared it
May
up.
I add to that just a touch?
Yes, please.
In one of my papers, I emphasized that most quantum reconstruction approaches take it as an axiom that there are repeatable measurements that give the same answers. And I tried to argue that I didn't find it a natural axiom. So actually, perhaps I'm disagreeing with Jacques. I simply made the statement that if you have a worldview where everything is novel, then actually that's the more mysterious of the options, that anything is repeatable. But so just to muddy the waters, Jacques, sorry.
I'm inclined to agree that Jacques shouldn't have added that to the QBist picture as well. I mean, why not say the same thing as you said about exchangeability, right? So you believe that you'll get the same repeated outcome, and that's all you could ever have. There isn't a fact that you will. So I can't see there'd be a difference in the case of exchangeability in the case of repeatability. The comparison with Einstein on source speed independence of the speed of light is a really interesting one. Yes, based on experiment, but also based on the ether theory. That's the key fact about ether theory is what's the point about waves in media, that they travel independent of the speed of the source. So that he even said somewhere that, you know, the essence, or maybe it was Pauli, the essence of the ether theory was retained in this proposition. So you're in danger of retaining anti-QBist essences in your repeatability in the world, I think.
I have no defense. I was going out on a limb.
It makes sense that QBism is itself subjective. So the next question I have is from Lev. Lev, go ahead. I'm gonna be mixing. There were some former questions for Jacques, but I want to also make sure that some of the questions for Chris Timpson get asked. So I'm going to go back and forth a little bit. So Lev, go ahead.
Just my question is different, but maybe I misunderstood Chris about ITER. ITER just says that it should be wrong, what Einstein said, or I just misunderstood it. Given the idea of ITER, we do not. I'm not sure.
It's about isotropy rather than source speed independence. So there are two components to the light postulate. One is independence of propagation of light from the speed of the source. The other is isotropy. So the ether makes you think that there should be isotropy. Should be failure of isotropy, but makes you think there should be source speed independence. Okay,
but so my main is just maybe also kind of psychological. I never had Chris or others, Chris Fuchs and others making the statement so strongly as you, Chris Timpson, said that one of the important points of QBism, it's rejection of reductionism program and rejection of microphysical laws. This seems to me kind of maybe as a physicist, or maybe I'm wrongly think that it seems to me that 99% of the physicists will say that it's against physics. So it's really, you said it radical. It's kind of, it seems to me completely against the whole idea of physics. So my question is it because, and you said that you're agnostic, you consider different theories. It's because you think that other interpretation failed that you go to this, or you still think it's on equal footing, even this kind of strange property, which I think majority of physicists, at least, will consider as complete no-go. It's because you think that other interpretation failed to provide something reasonable.
Yeah, thanks, Lev. So I think we can ask why physicists are typically committed to this kind of reductionist view. We need to be a bit careful because reductionist views come in lots of different kinds of strengths. And the problems about explanation that I pointed to or tried to point to are, I think, the cash value of the genuine concerns that physicists would have. So if those explanation concerns can't be met, then I agree that it's game over for the QBists. But there's an interplay in our commitment to the existence of certain levels of detail in our microphysical laws and the possibility of giving explanations of the things we find around us. Those two things interplay with one another. So it is there are various different views in the philosophy of science that reject aspects of the reductionist picture. Nancy Cartwright has an interesting rejection of what she calls fundamentalism, which presents, the idea that, so she allows there can be plenty of reductive relationships between certain bits of physics and other sciences, but denies that physical laws have universal scope in that they treat everything all in the same kind of way. It's actually quite hard really to pin down what's wrong with that view. And it tends to go by way of saying that actually, when you look hard, it turns out that you can't get all the explanations that we think we do have in physics. So I agree that there's a lot at stake here, but I don't think it's settled so quickly just by saying, physicists would throw this out. I can ask why would they, and what exactly is wrong. So that's what I think we need to look at. I think the explanationist challenge, the challenge from explanation is the real challenge here. But I think it is really important. You're right.
So just to be sure, today it's not clear that there is a fully successful reductionist program. There are some clouds in science. We're still not sure that we understand everything. But if tomorrow physicists will say everything is clear, everything fits, no problem whatsoever. And there is this reductionism program with microphysics and with some kind of interpretation. Still, QBism will have some reasons to exist. It will help for some, because you mentioned that it brings some advantages, and you never spelled out what are advantages which you can get from QBism. So if the reductionist program is successful completely, still it can be completed or improved somehow with ideas from QBism.
The advantages to do with QBism that none of us really talked about today were resolving the measurement problem in a single world way whilst retaining locality. Okay.
A single world. Okay.
So those are some of the advantages. I mean, it's just not the questions that hang from a philosophy of science point of view over the scope and nature of reduction relations between different parts of science don't really depend on the general questions don't really depend on the detail of whether particular completions of, say, high energy physics are going to go in one particular way, or whether quantum gravity is going to come another particular way. That's not really where the concern is. It's more to do with what's involved in reductive relations between different parts of science anyway, and the extent to which fundamental microscopic laws which are universal in scope and operate in the same way across all domains, to what extent that's actually a necessary condition for reduction. You can argue that it's not a necessary condition for reduction, and that you can get plenty of interesting local pieces of reduction going on between different areas without that assumption. The striking thing that the QBists offer is they just say, actually, no, we just, for independent reasons, we're going to throw away the fundamental level, not just for Nancy Cartwright reasons that she doesn't see positive arguments for the existence of universal microscopic fundamental laws, but rather because they think they've got positive arguments against such things because of the oddity of what the world would have to be like if we did have such things, Everett, the Bohm, and so on. So I'll just say it again, the stakes are high, but they're not, the matters aren't going to be resolved quickly. And it's not really, post-standard model physics, which is going to settle the question about the nature of reduction.
Okay, thank you. It helps.
Lev. I just want to note that Michelle in the chat wrote, the idea that there are no laws of the microphysical domain is also compatible with von Frossen's remark that the so-called laws of nature are in fact laws of physical formalisms. I don't know if people would like to comment on that, or if Michelle wanted people to comment on that, but I know you put it in the chat, so.
That sounds right.
I have a somewhat, I think this is kind of connected to that, and also connected to the previous point about explanation. I think Chris Timpson is really on point to say that the stakes are high, and I think Lev is correct to say you can't just throw out reductionism and model-based explanation without replacing it with something else. And I do think the challenge is to come up with a kind of QBist-oriented notion of what explanation means. But I don't think it's necessarily an impossible challenge, because consider models, for example, model-based explanation. We can potentially make use of models in QBism as long as we don't think of those models as being representations of how the world is, but we think of them in a different way. So think what it means to not have an explanation for something. It means you're surprised by what happens. If you had no explanations for things, you'd be walking around being surprised all the time. So when you have a model which explains something, what it really means is that you have a set of constraints on your interconnected beliefs, which basically allows you to not be so surprised all the time. So I would venture tentatively to say that if we think about physical models as being constraints on our mesh of beliefs, which kind of maximally reduce, or I should say, which minimize our surprise over the widest set of possible experiments, then we can treat that as an notion of explanation in QBism. It's a model-based reduction of surprise.
I don't think that works. That's what my comments about expecting and expressing expectation is. So you talk about constraints on belief. What's the nature of the constraints? Is it just that one in fact happens to have one's beliefs organized in such and such a way? Because that's what the QBist has. If the model involves, for example, a particular Hamiltonian and a particular state, then it just happens that their beliefs are that way. It's not that they're responsive to things. So yes, we can deploy models, but then try it, saying, well, there are these little electrons and they're going around in this kind of way, and their state means that their velocities, their average velocity will be blah, or the charge distribution will be blah, blah. By the way, there aren't any facts about what the states are. So you just add the metaphysical claim at the end of the putative model and see whether you think you've still got an explanation. Usually it's like, a story can make you feel good, but then if you add, by the way, none of that's true, it doesn't really help in structuring our expectations in the right kind of way.
Yeah, I don't know. When you say, by the way, none of that's true, I feel as if there's a lurking disagreement here about what truth means. I'm very much a pragmatist on that score. So I would say, well, it's true as long as it succeeds in making you less surprised about what happens next. And for me, it doesn't have to, be true in the sense of matching some.
I mean, that view of truth won't work in general. But that's the extent and the problems for pragmatists' account of truth are a large topic. But at least I'll say that I'm persuaded that move works, not least because pragmatists frustratingly never distinguish enough between questions about meaning and questions about truth.
I may well be in over my head on this one.
So it's all right. I'd like to move on to other questions, but this was a really interesting exchange. Barry, I saw your hand went up and then down and then up again. So what's up? Oh, you're muted. Barry, you're muted.
I want to make a quick remark after Chris's, just 1 second. Quick remark after Chris's statement about pragmatism, because it brings to mind Sidney Morgenbesser's famous remark that the trouble with pragmatism is that while it's true, it just doesn't work. I can't talk. I have to answer the phone, so I can't give ask my question right now, but if there's time later, I'll get back to me.
I'll come back to you, Barry. Okay. So the next one I have is Wayne.
Okay, so first of all, I'd like to thank Jacob for organizing this particular sequence of talks, because putting these three together has helped me crystallize where I actually, what my disagreements with QBism, or where I think our differences are. For those of you who don't know me, I'm one of those philosophers that Chris was talking about, who has written about QBism. And Chris Fuchs, at the beginning of his talk, characterizes the response of philosophers as basically starting from a more realistic presupposition and complaining that QBism isn't realist enough. And that doesn't characterize any of the philosophical literature on QBism that I'm aware of. But something that Chris said, I should say Fuchs, something that Chris Fuchs said in the discussion, I think crystallizes something. He quoted Rob Speckens as saying, we've got this basic idea that we're not going to back down from, that the quantum state is to be interpreted in emissive terms. And some philosophers, including myself, think, okay, when you're going about investigating the physical world, or the natural world, there shouldn't be anything that you decide at the beginning you're not going to back down from. You start with certain presuppositions about the world. Some of them might be fairly well entrenched, but you ought to be willing to give them up in the light of evidence. And then another thing that Jacques said was, well, we're just not going to, when you're dealing with things and you do some kind of operation and then you form expectations about the results of further experiments. We're not going to say there's any hidden variables carrying the memory of what occurs. And that's, I think, a very important element of QBism, in that that's why the the psi ontology theorems like the PBR theorem don't get started, because they presume that it's okay to, when you're dealing with something, to theorize about it and attribute physical states to it. And before you get to the PBR theorem, there's a sort of mini, very basic theorem of that framework, that if you've got a pair of preparations that you think you can reliably distinguish from between later on, then you should think that those are ontically distinct, that they produce physically different states. And if I understand, QBism is just not going to even talk about the physical states of things. And first of all, do you really believe that? And why should anyone do that? So the question is, for example, when you've got a laptop and you're using it as an aid to memory, and so you're making choices between operations you can do today, do you not think that if, let's suppose you believe that your choices of keystrokes to make today makes a difference to what you are going to see tomorrow, do you really, for the question for both Jacques and Chris Fuchs, do you really not believe that those differences make differences in the physical state of the thing that you later find out about?
Jacques, you're younger than me.
Could you restate the question? I didn't quite understand. So you're asking whether, do I really believe that
you've got some physical system?
Yeah, my laptop.
And you're using it to take notes on. So you're making choices of keystrokes. If you believe that your choices of keystrokes today will make a difference to your experiences tomorrow, so that tomorrow you'll be able to find out, because you've forgotten, right, about what keystrokes is made today. Do you not believe? So in an email, Chris Fuchs, after my talk about a month ago, Chris Fuchs says, well, we eliminate the middleman. We just talk about our experiences today, our experiences more. Do you not believe that your choices of keystrokes today?
Did I say that? I don't remember writing this, Wayne.
Yeah.
Don't worry about it. Don't worry about it.
Yeah. Anyways, you did. Yeah. All right.
Jacques, I'll take the question if you don't want it.
Okay.
Yeah. I
Right.
thought you were young and you should speak, but
apparently I'm getting old fast.
So what Wayne is saying is one cannot, or it seems to him, this is my translation of you, Wayne. It's hard to imagine a world without substances and properties.
No,
in other words,
that is not a translation of what I was saying.
So when I type on my keyboard, I change the ontic state of it, and that's why I can come back and find it tomorrow. And you're asking me, do I really not believe that?
Yeah.
And I'm going to say, I really don't believe that. And the reason I don't believe that is the weight of the evidence of all my other thinking. So now, unfortunately,
so why are you doing it?
That's private to me. You haven't spent 20 years reading William James and John Dewey, and maybe you'll say, well, with good reason, I haven't wasted my time, because it'll lead me down that crazy path that Chris Fuchs went down. But they tried to imagine a world that had all the reproducibility you could ever need, but without these stabilized ontic, I don't know quite which words I should use for the project, a world without that, So, I mean, in general, the debate between you and me, I think, boils down to, I'm willing to say that quantum states are epistemic about experiences, And you're saying the only reasonable notion that one could explore is that they are epistemic about ontic properties. They're states of knowledge or belief about what is in the world, rather than about direct experience like Jacques was bringing up earlier. And I think the notion is broader. And by the way, yes, I said something much too strongly when I quoted Specken saying one should never abandon the conception. If it had enough problems, I would abandon it. But so far, it has seemed to me that it has only led to productive things, but it's a long-term project. And Chris Timpson is absolutely right that there's a lot of work to do remaining to really make it all airtight. But life is short, and I can only do one thing, so I'm sticking with this because I might be successful. If I play with 15 interpretations, I'll end up in a philosophy department, and that'll be the end of my physics career.
You'd
And
love
I
it.
guess I don't want to take more time, but I just want to say I think that's another difference between like some of the QBists and some of the philosophers is, I'm not sitting here saying I'm a physicist. I need a research program that's going to result in published papers publishable in physics journals. So I want something that's a fruitful source of interesting questions to ask. And I think that's I'm sitting and asking, well, what do I think that the success of quantum theory is telling us about the world? And I think those are very different questions that really should be kept more distinct. You could regard QBism as a fruitful source of problems and conjectures and theorems to prove and stuff like that, without commitment either way to the actual, ontic status of quantum states one way or another.
I'll let you have the last word.
This comes back a bit to the point that, well, for me at least, one of the interesting things about QBism is that it raises new questions and points us to new problems that need to be solved and new challenges. And that only happens when you take a pretty strong stance about ontology and you don't remain agnostic. So I'm against remaining agnostic. I'm saying let's find out all the consequences and where this leads. And if it leads somewhere crazy, we'll know we have to do something else. And if it works, it might actually be productive in the sense not of generating scientific papers per se, but in the sense of generating a new way of thinking about the universe.
Can I just follow up very quickly? So I just want to make sure I understood one key part of this exchange. So at one point, Wayne asked, if I type on my laptop something today, am I changing something about the ontic state of the universe?
For the laptop.
For the laptop,
yeah.
And if I heard correctly, I think Chris said that you didn't agree with that interpretation. Did I mishear that?
No.
Okay.
No.
Yeah, it's a very interesting point, and I think it distills a lot of high-level discussion about QBism down to something that is very interesting, and I would argue controversial. I mean, it almost has echoes of like Samuel Johnson and Bishop Berkeley, right? Like, but maybe not. I mean, it's interesting. I have to think about it.
It does. I mean, I'll just add that QBism makes one's life easier here because it's precisely a case which, insofar as the laptop is well described by classical physics, which mostly it is, apart from the details of how the noughts and ones go, then you can have physical facts about how it behaves while still maintaining a QBist position.
Wayne, I saw you shaking your head.
Yeah, Chris Timpson, you were the one who brought up semiconductors,
Yeah,
and
right. I'll take it back.
right, and it's been a long time since I've taken an electronics course, but I think whatever the memory in this is, I'm sure it's got something to do with doped semiconductors.
Right. Let me scratch on a wax tablet instead.
Okay.
Yeah, this is probably beside the point, but I just want to show, or at least give some evidence that I'm not so intellectually isolated as Jacob just made me sound.
No, no, I didn't mean it in that way at all. It was genuinely
And
interesting.
for this,
I meant nothing pejorative by it whatsoever.
I'll just bring up a discussion in one of Whitehead's books from the 20s or 30s, a discussion about Victoria's Needle in London. Here's this, I think it's Victoria's Needle. Do I have it incorrect, Chris?
Cleopatra's Needle, the Albert Memorial.
Cleopatra's Needle. Cleopatra's Needle. So it's a stone monument that was stolen and put in place in London. And he says that every day, day after day, it persists because nothing is changing. But he tries to construct a philosophy where, despite the persistence, and whether he's successful at it or not, I'm not going to get into now, but he tries to construct a philosophy in which the persistence is actually a statement of rebirth continuously. And so I don't know exactly how to flesh out a really good answer to Wayne yet, but I feel it's along those lines of thinking. So 20 years from now, Wayne, if I don't have an answer for you, then I'll say, well, hell, maybe Wayne was on the right track after all.
I look forward to the next 20 years of discussing this. It has been about 20 years since we've been talking about these things.
It has indeed.
Great. We have a couple more questions. I'm going to exercise my organizer's prerogative and ask a question I've wondered for quite some time. And it's related to something that I asked earlier about the dichotomy between ontology and epistemology, and where nomology, laws, live in that story. Because this may just be from my perspective, but nomology seems to have its own status, perhaps, arguably distinct from ontology and epistemology. And actually, my question is a little more narrow than that. There's a more narrow aspect of this that I wanted to ask you about, and it's inspired by something that's shown up in some of John Ehrman's papers. John's not here today, and I don't want to speak for him, so I apologize in advance if I'm mischaracterizing his position. I'll just phrase it as my own. But one of the laws or rules or methods that we use in quantum mechanics, after we do a measurement, in traditional textbook quantum mechanics, we do an update of the state vector or a collapse, whatever you want to call it. In general, this is something like a von Neumann-Luder's projection. We go from our original quantum state to some new quantum state. And, to the extent that we can think of a quantum state as being nothing more than a convenient mathematical abstraction that is just a collection of all of our subjective probabilities. Once you know enough probabilities, this uniquely determines the quantum state. What John Ehrman, the way he phrased that is, you've got a lattice of projections, the projectors, the true or false propositions. And a set of probabilities is an assignment of all of those things to probabilities, subjective assignment to all of some collection of projectors, or all of them, to probabilities. And the goal would be to be able to say, okay, I've got my initial quantum state, which is some initial probability map that assigns all the projectors to probabilities. And then after I do my measurement, there's some collapse or update process, whatever you want to call it, and now I have a new probability map that assigns new values to all the projectors. And Ehrman's concern was that in order to make a prediction, a theoretical prediction about what the new probability map is going to be, and I mean a theoretical prediction, not that you just do it and then you go remeasure all of the probabilities, but or not measure them, but you assign them in some way. But if you want to predict at least what textbook quantum mechanics says should be the correct, theoretically speaking, the correct final probability map, there's an intermediate step in which you have to use a full quantum state map, because the von Neumann-Luder's projection rule, it involves, if you do an ideal measurement onto some particular projector, you got to stick that projector corresponding to the measurement outcome into a full-blooded quantum state map, And then from this, you derive a new quantum state from which you can then get all the probabilities. And he was concerned that at an intermediate step, you seem to be needing to use something that was more than just a map on projectors, something that was a full-bloodied quantum state that assigned expectation values or numerical values to all the elements of the algebra. In order to make a correct, textbook correct prediction about what the final quantum state is, even if you regard it as subjective. So this might even be addressed by the tomography discussion, that there isn't an objective answer to what happens after you do a quantum measurement. But I just wanted to take the opportunity to ask this question, because I know that he was wondering, and I'm also wondering it.
We don't need anything but quantum information theory and Mike Nielsen and I Chuang's book on quantum information and computation to know that consequent upon a measurement, there is not a unique quantum state assignment. It depends upon the details of the measurement model. So Krauss in the early 70s disabused physicists of the idea that the von Neumann rule was anything special, nor Luther's rule was anything special. And in fact, one could have any update based on any completely positive map.
Okay.
So I don't know if that really addresses your question, but
yeah, it's quite helpful, actually. Yeah.
But at least for the quantum information community, there's no special status to von Neumann's collapse or to Luther's rule collapse. They're just one among an infinite number of options. And if one is drawn to some even more radical forms of subjectivism than James's in probability theory, Bas van Frossen's reflection principle, then one will say, oh, that's a natural property of quantum mechanics. After all, that that you can't give Dutch book arguments for state change rules. Van Frossen Ian Hacking pointed that out first, I believe. Hacking pointed it out first, and Van Frossen later ran with it, that there's no Dutch book argument. Oh, and I think Wayne's colleague also was deeply involved. I can't remember his name anymore. Man with a lot of white hair and a beard. Was deeply involved in these kinds of arguments in the 70s. So for whatever that's worth.
Very helpful. So we're unfortunately going to have to leave it there. I know there were a couple of remaining questions, but I want to be fair to everybody, especially people who are in time zones where it's quite late. Thank you to everybody. Thank you to our three speakers, Chris, Jacques, and Chris, for wonderful talks and wonderful Q&A and discussion. Thank you so much for your time and your energy into all of this. This has been incredibly interesting and informative. And thanks to everybody who participated, whether you had questions or not. It's wonderful to see all of you. I hope you're all doing okay. Stay tuned for an announcement about the next workshop. And until then, be well, everybody.
Thanks, Jacob.
Yeah, thanks very much, Jacob. And I'm glad you're putting this on YouTube. It'll be nice to see the reactions to this discussion.
Yes, so please beware. It'll all be on YouTube.